Hi students, now we are going to explain the variation of acceleration due to gravity with depth. Now as we have already derived an expression for the variation of g with height, I told you, either if the object is placed on the surface of the earth or above the surface of the earth, the entire mass of the earth will pull the object. Whereas when you go below the surface of the earth, only the sphere below your foot and its mass is going to contribute for the gravitational pull. Anyhow, this topic we are going to derive by assuming the earth as a homogeneous sphere. That means we have to assume that the density of the earth is a constant. In geography, you must have studied that the different regions of the earth, like the crust, mantle and the core, actually they do not have the same density. It differs. But here we have to assume that the earth is having a constant density at all points inside the earth. Okay students, now look at the diagram now. I have kept an object of mass small m at a point A on the surface of the earth. Then I will assume another point B inside the surface, okay, below the surface of the earth at a depth D, okay. So that now I will explain the terms. What is the m here is the mass of the earth, the total mass of the entire earth, and Re is its radius. Re, okay, is the actual radius of the earth in total, and small m is the mass of the object which is placed at A as well as B, and D represents what? The depth below the surface of the earth, and M dash is the mass of the smaller sphere at a depth D, and V dash is its volume of the smaller sphere. I will take this as what? V dash. So mass of the total earth is capital M, and its volume I will take as V. V is the volume of the entire earth, and M dash is the mass of the smaller sphere on which the object is placed at B, and its volume is V dash. Now the density rho is constant. So this is mass of the entire earth M divided by the volume of the entire earth. Or this also must be equal to what? M dash divided by V dash. So this is our assumption here. After this we will go to the derivation now. Okay. So first I will take at a point, that is at point A. So this is on the surface of the earth. The acceleration due to gravity G is equal to what? Capital G into mass of the earth divided by Re square. You can use the symbol ME also, but here let us assume capital M itself is the total mass of the earth. So small g is equal to G into M divided by Re square. Now since rho is equal to capital M divided by V, I will substitute capital M is equal to rho into V. So this M can be substituted. So this is equal to what? G into, instead of capital M, I can substitute rho into V. So this is a density rho into V divided by Re square. Okay. So volume of the entire earth, volume of a sphere I am going to substitute, that's all. Or G is now equal to capital G into rho into volume of the sphere is 4 by 3 pi into R cube, and this is whole divided by what? Re square. Okay. So this Re square get cancelled with the power 3. So only Re will remain in the numerator. Therefore now we get small g is equal to this 4 by 3 is a constant. I will write first 4 by 3. Pi also I will write 4 by 3 pi g rho into Re only will remain, because R cube by R square is equal to what? Re. there will be no other term in the denominator because 4 by 3 is shifted to the numerator. So this is equal to 4 by 3 pi g rho into Re. So this is the required equation 1. Now, if I will assume that mass m is shifted to a point B, which is at a depth d below the surface, now what will be the actual distance of this mass from the center of the earth? It will be Re minus d, is it not? Re minus d. That is also equal to the radius of the smaller sphere. I told you that when you go below the surface of the earth and stand at a point B, the sphere which is below the feet, that much mass only is going to pull you down. Understand that? So now I will take another point, that is at a point B. So this is at a depth D. At a depth D. For this I will take the symbol G suffix D. Understand that? And this is equal to capital G into mass of the smaller sphere is m dash divided by distance square is what? Re minus d the whole square. Is it not? Re minus d is the distance of the mass m from the center. So Re minus d the whole square, and this is equal to capital G into. Now rho is assumed to be constant. So it is also equal to what? M dash by V dash, where M dash is the mass of the smaller sphere and V dash is the volume of the smaller sphere. So I can also write M dash as a product of rho into V dash. Is it not that? So this also can be written as the product of rho into V dash divided by Re minus d the whole square. Now I am going to substitute V dash. The volume of the smaller sphere is equal to 4 by 3 pi into Re minus d the whole cube. So this is now equal to, so G d is now equal to capital G into rho into 4 by 3 pi into Re minus d the whole cube divided by Re minus d the whole square. Once again, this is x cube divided by x square, so that the value of x will remain in the numerator. So I will write G d is equal to, in the same type of format I will write 4 by 3 pi I will write first. So this is equal to what? 4 by 3 pi G into rho. Okay. 4 by 3 pi into G into rho. The remaining term in the numerator is what? Into Re minus d. And this is the required equation number 2. Have you all understood up to this? First, I have got an expression for small g by taking the total mass of the earth and the total volume V. Understand that? Next, at a point B, I have substituted the mass of the smaller sphere on which the object is placed, and in terms of volume V dash. So I got the equation number 2. Now dividing equation 2 by equation 1. So dividing equation 2 by equation 1. Left hand side is G d divided by G is equal to, the right hand side if I divide means 4 by 3, okay, 4 by 3 pi G rho into Re minus d whole divided by the right hand side of equation 1, that is what? 4 by 3 pi G rho into Re. Okay students, now so many factors will be cancelled. This 4 by 3 pi G rho all will get cancelled, so that this is equal to Re minus d divided by Re. Okay, so this is equal to Re by Re is 1 minus d by Re. This will remain. Therefore G at a certain depth is equal to G multiplied by 1 minus d by Re. This is the required final equation number 3. Okay, children. So, if you open up the bracket, first term is g into 1 is g. G minus or something must be again less than g itself. So, here also we will write that g at a certain depth is found to be less than g. So, we conclude, okay, what do we conclude? Hence, value of g decreases, value of g decreases with increase in depth. Now care must be taken that if you take g at a certain height, for height we got g into 1 minus 2h by r, but for depth it is only g into 1 minus d by r. Okay. Now as a special case, suppose at the center of the earth, if you keep this mass m, what will be the distance of the mass from the center will become 0. So if d is equal to r, see at center of the earth, this depth is equal to what? The radius of the earth itself. So d by re will become 1, 1 minus 1 will become 0, therefore g is equal to 0 at the center of the earth. So what will be the weight experienced by this mass? That is equal to 0. This is also called as what? Weightlessness. Already weightlessness in a lift we have studied. Same like that here, weightlessness is experienced by any mass placed exactly at the center of the earth. Okay children, so we have derived an expression for the variation of acceleration due to gravity with depth by assuming a homogeneous sphere. That is, the density of the earth is considered to be constant everywhere. So we started with what? The expression for g on the surface, and then at a point b, then we divided and got an expression gd is equal to g into 1 minus d by r. I hope you must have understood that. Fine.